Thank you for coming, everybody, and hope you enjoyed your lunch. Thank you, Tomek, for introduction. Just to give you a few things about me. Over the course of the last couple of months, I traveled to Australia, so all the background images you've seen in the slides are from somewhere in Australia. I'm gonna ask all Australians afterwards where they are from. That's one of the things, that's why I have Traveler on the slides. And the other thing is that I'm a Django core developer. I apparently started contributing on a regular basis in 2014. And then at the beginning of 2015, the core team back then was apparently too lazy to merge all my pull requests and decided it might be a good idea for me to do it myself. So that's why I ended up and, well, became a core developer. Django's migration framework was introduced in Django 1.7, and thanks, Andrew, for doing the burden of getting that into Django and developing it. There's a lot of things that happened to the migration framework since then. There's heaps of bugs that have been fixed. 1.7.1 had about 50 bugs fixes in regards to migrations. There have been improvements for speed and features, and well, there's a lot of that stuff that happened. However, there's still things that are bugs that are not yet possible or might not even be possible at all to be automated by Django. So at some point you end up writing your own migrations. And that might be a bit scary, but that's why I want to came up with 3 recipes for this talk that I want to give you at hand to then explore the world of migrations, and whenever you encounter problems, well, read the migrations that are in this talk, read migrations that other projects use, and solve the problem by writing your migrations manually. The make migrations management command does a lot of stuff right, but there are things it just can't do because it's just beyond the scope of every normal or every regular project. Side note, the examples I'm going to show in this talk are all based on, well, Postgres, because everybody wants to use Postgres. SQLite might work, it might just blow up, depending on how you use foreign keys, because SQLite does not necessarily enforce them. If you use MySQL, okay. If you use Oracle, I didn't take the time of setting up an Oracle instance, and so didn't really care about it, because when you run on Oracle, you mostly have a DBA anyways, and they should know how to deal with your database. But before we go into any concrete examples, I want to give you a general layout of how the migration system looks like. And first off, you have a class called migration, which inherits from django.db.migrations.migration. And it's essential that this Python file, has exactly this one class migration in there. There can be other stuff in there, but there has to be a class called migration that inherits from migrations.migration, or some other migration classes if you have your project level, whatever. Then there's an attribute called dependencies, and that defines where in the entire set of all the migrations you have in your entire project with all the third-party apps installed and all your apps you have installed lives, as in, I have my migrations, this particular migration, but before I want to run this, there's this migration that has to run first. So let's take a user and a profile, and they respond to 2 tables in the database. And when the profile refers to a user, well, on database level, you have to have a foreign keys there, and to create a foreign key, this table needs to exist. So a dependency for the profile migration would be to depend on the user. The other thing, which is, well, probably the key part of an entire migration, is the operations attribute. And this is a list of classes, create model. You might have seen that when you looked at migrations, add field, alter field, remove field, and all those things. And they are, well, part of the heart of the migration framework. They do the kind of heavy lifting to tell the database what's happening. And the operations are run, well, in chronological order when you apply migration. They are run in reverse order when you unapply migration. So that means when you have a create model operation in there, well, when you apply migration, the database table is created. When you unapply migration, well, this table is discarded and removed. All right, let's start with the first recipe. And this is where I want to optimize the output of the make migrations management command. This is the precise example here is not necessarily something somebody needs to do who starts off with a very small project. It's something you want to look into when you have this huge project with dozens of models that somehow relate to each other, and then you add two apps that have a certain dependency to each other, two models that have a certain dependency to each other. Let's take this example. You have a book model and a library. The library has, well, a name, and the book refers to a particular library, because a book can only exist in one library. I haven't seen a book being coexisting in two places. So when you run make migrations, Django outputs these three things, or outputs this text to the command line. So let's look into how the migration that was created actually looks like. And, well, we have, as mentioned earlier, the migration class here. We have no dependencies because it's the first migration in this app. And the next one is a list of operations, the first one being the create model. Interestingly here, though we didn't define a primary key explicitly in our model, it is here. And we have the title that we defined, but the foreign key we defined to the library, well, that's somewhere else, but not there. The next thing is the create model operation for the library. And as this looks pretty much the way we would expect it to look like. We have the primary key and we have the name. The interesting thing here is that Django comes up with a third operation that, well, adds the foreign key on the book to the library. Why is that? Well, there's one thing make migrations has to be, and that is reliable and deterministic. And to achieve that, make migrations creates or adds foreign keys or relationships between models always at the end of a migration. Because when we have all tables created, for example, we know that we can add all the foreign keys we want to add. Secondly, Django's migration process or make migrations command processes all models in alphabetical order. And last time I checked, book was before library. There's a third thing though, and that is that, well, nobody has contributed a patch for fixing that. And quite frankly, I didn't have the time and didn't bother to do that myself yet. Anyhow, how do you think we could optimize that? And I suppose a couple of you already have an idea. And it's, I think, rather straightforward when you rethink what I said before, that when we create a model library first, we already have the database table that belongs there. So we can then, in a create model operation for the book, includes the foreign key. As said initially, this is not something somebody starting off with a very, very small project needs to do. This is something you want to look into when you have 100 models, because then having one less operation, especially with regards to foreign key, may make a huge difference on the performance of this particular migration. Let's go to recipe 2, adding a non-nullable column. So we have our models, we have our project definitions, and all the definitions of our project, well, not all of them, but many of them change over time. And the way our project requirements change, also our models change. And what that means is that we may end up with an author model at some point. And we want to add a field there, but we kind of have the requirement it must not be null because it's it has to be there, but what do we do with existing data? The create model in this example is just a demo thing for all the places in your entire project where you create a model or create an author. So if it's in a view and you run create author.objects.create, this is a this is a thing for that. If you have your form, this is an alias for that. So you probably wouldn't write it this way, but just take this as something that applies to everything, every place in your project where you create an author model. And when you create the respective migrations and apply them, then, well, you end up with the create author model here. To make sure we have an example that actually makes sense and where we can actually show that the entire idea or the entire recipe works, we need some initial data. And for that, we create an empty migration, and then we are going to create initial data in there. And that may look like this. We again have our migration class. We have the dependency to the previous migration. And then there's an operation called run Python. And that takes two functions, one being the forwards function, one being the backwards function. And I think this code is straightforward for everybody in the room. We get the model we want to use and create two authors, or we get the model and delete those two authors in the backwards operation. So let's apply those two migrations. And this is what we get. Django is rendering the model states, applying migration 000 initial and 0002 initial data. Everything fine. So I said we want to, our requirements change, so we want to add something to the author, which must not be nullable. So let's take the homepage, for example, because that makes sense on the author. All the information to that author is on his homepage. So why do we have the null there? Because we don't have any information about the data in the database yet. So when we want to make it null, not nullable, then we can't just do it right now. So we need to take an additional step to make it nullable, and gonna switch over in a later step. So we start with creating the migration and applying the migration. This is migration 3 in this example. And then when we have this applied to deployed to production, we can actually, well, use the code. We can, whenever we create an author, we also make sure that we set a homepage. That means for every new author we are creating, we will have a homepage in this database record. That also means that whenever we read the homepage, we may have either a null value or a homepage that is defined. So we need to take care of both cases, which is why we have the if self.homepage in this tag down there. Now let's take the next step. Since we have records in our database that don't have a homepage, we need to populate existing data to those records. And this is done by another migration. We call that populate data. And what we do here is that we need to have a source for the value we want to have for the homepage. We need to have a value for every single object that does not have a value yet. So this value might come from a CSV file, from an API call, although I would not recommend to do that. But it doesn't really matter where it comes from, as long as you have a value for every single value in your database. And then we iterate over all authors that don't have a homepage yet, set the homepage, save the author, well, and are done. When we apply the migration, we now can ensure, or we know that the migration, that all the authors in this database table will have now homepage, because all the new authors already got the homepage. All the pre-existing authors, well, they got a homepage during the migration. That means that at this point, we can drop the nullable constraint and make this field not nullable. since this is a change to the model, we have to create a migration. And since Django does not really know what we did underneath, Django is going to ask for what we want to do, since Django thinks, well, you might have data in the database that is null, and you make it not null, this is going to blow up and blow in your face. No, we know it's not because we took care of that. So we can go with option 2 and say, ignore for now because I know what I'm doing. Well, famous last words. So let's create the migration. Everything's fine. This is what it looks like. We have an author field that changes the URL field to a one with null equals false. Applying the migration, and if you didn't make any mistakes, that works. Now that we have we know that every author has a homepage defined, we can get rid of some dead code that's not ever going to be executed. So clean up after yourself. All right. Since these two were already, well, a bit intense, the first one I think was fairly straightforward. The second one was already a bit complicated. I hope I didn't lose anybody yet, though. Here's recipe 3. And no, it's not the most complicated I was able to come up with. That would have spent more than the talk would able to fit. But I think it's still straightforward. If you don't understand it just yet, look at it later. I will upload a repository with the examples, and whenever I come up with something that might make sense to have as a generic recipe, I will publish that as part of this GitHub repository with examples. The idea here is that, well, you start off a project, and at some point you add a new app, and for whatever reason, this app has this name A, and at some point you will say, oh no, actually I want to rename this. This was a bit harder before migrations were there, and it's not particularly easy right now, but it's still possible. But for the simplicity of this example, you must not have any foreign keys to any model pointing in there. Outgoing foreign keys shouldn't make a big difference, but incoming foreign keys may prove as a pain point. So let's start off with the author and the book model again, because we all love books and authors. So we have this foreign key from a book to an author, and I think it's pretty straightforward. We create the migrations. We create an initial migration, which is pretty much similar to the one we had in the second recipe. And, well, we apply all of those. The next thing, since we want to rename the app, we also, or Django internally, will also rename, or would also expect the database tables to be available at a different name. A different name means that, well, the tables don't exist if you don't create them. There's one thing in Django, in the models meta class, where you can define the explicit table name Django should use for this model. And by defining then that explicit to the current value, which is app name underscore model name, Django is not going to use anything else but this name. Since this is a change to the model, you end up with migrations, with one migration that pins this database table name to the entire migration part at this point. Well, new migration means let's apply that one, which is the last part here. I skipped the output. So when we have everything applied, we have the idea here comes up that our database looks the way as it's supposed to be, but we could technically change since we can pinpoint the table names of a model, we can pretty much change the name of the model, the name of the app, whatever we want. That because we have a fixed table name. And we can do that by rewinding or unapplying all migrations in this app. I think most of you probably have not used that, and you should be careful with using --fake. especially when you apply a migration, but unapplying a migration, especially with -- fake, does not necessarily prove anything, or does not necessarily break anything. So the fake operation pretty much says that Django only collects these migration and thinks, okay, I have not applied them, but didn't really touch the underlying database at all. So after this, all your database tables are still there. The only thing Django thinks is, well, I don't know anything about those, oh, I haven't seen these migrations as applied. The value 0 you see in the command up there tells Django to go before the very first migration of this particular app. So if your migration numbers start with 0001, then putting 0001 at this place would unapply 02, 03, or 04, whatever you have, but would keep around 01. That means if you want to unapply 01, you have to have something which is before that, and that is the string 0. Now that Django doesn't know anything about these migrations anymore, we can rename the apps. That means we rename the files, we change the name in the installed apps, in the foreign keys, in the dependencies within migrations. There's only one place in the entire app where you must not change the name. And understandably, this is the table name, the DB table attribute. Because this is still the same value, the table is still named the same way as before. Well, now that everything is moved somewhere else, let's fake apply all of those. And since we didn't really change anything, let's just tell Django, well, consider those applied because, well, we did that before already. And at this point, well, everything should just work again. There's one thing you can then clean up, and this is an optional point, though I probably would recommend it. You can remove the DB table attribute from the models again. And again, since this is changed to the database or to the model, there will be a migration. And this one you have to apply as well. In this particular migration, Django is then going to rename the tables to the new app name author, new app name book, including resolving foreign keys between those apps or these tables and so on. All right. I think this is a fairly complex topic, so I try to keep this talk fairly short and want to have lots of questions from the audience, because I think that providing a bunch of examples, or 4, 5, 6, whatever examples here, is not particularly too helpful to everybody. I think it's having concrete examples from your project and trying to answer them here, or give you ideas of where to look into or how to proceed there, is more helpful. All right?
Thank you very much, Markus. We've got around 7 minutes to do the questions. So please come here. Who wants to go first?
Hi. The question I would like to ask is that if I have a third-party external Django application with some models,
yes,
which for whatever reason later I decide to remove from my project,
yes,
how do I get rid of the tables in the database?
How do you get?
How do I write a migration to get rid of those tables in the database, but obviously it's a third-party Django application, so I can't really, generate migrations inside that application for it.
So the first thing you need to make sure is that all your apps or everything you have on your side does not refer there anymore. So apply all of this, and then unapply the third-party package. So go for migrate third-party package name 0. And that should just, well, that drops all those operations. That should just work. One thing, make sure that you don't have any dependencies in any of your migrations to that app. Yeah.
Hi. I have a question about renaming models or fields in migrations. Does Django rename, in Postgres, for example, does it rename also the constraints and the indexes as well, like the fields and the models, or create them with new names?
The constraints names are not renamed last time I checked. This is though I think there's an issue of open on the bug tracker to do that. Yeah. Okay. We should do that, yes.
Okay, and one more question. And is there any difference between creating two separate migrations where the first one sets the data for non-nullable fields, and a second one which removes the null from the field, or between this scenario and the second one is just create a run Python method before removing the null true field?
There's a difference, especially on Postgres. DDL operations may not allow changes to the values within the same database transaction. Every migration is run within its own transaction, which means that the transaction is opened. Django is doing some DDL operations, creating a column, whatever. When you would then want to insert something in this column, your Postgres is going to say, oh, no, I don't do that. And, well, it blows up.
Okay, thank you.
More comments than a question. No?
Go for it.
About removing an app, just a continuation of the former question.
Okay.
When you say you need to make sure that there are no dependencies left in migrations,
yes,
this then potentially means that you need to go and fix older migrations, and that would be a real problem. Like, so in order to really do this properly, you would need to do like really serious squashing of migrations to get rid of all the operations that created the dependencies. And it's really not very simple. Sorry.
That depends on how the dependencies are. You might get away with it just removing the line from the dependencies.
Guys, I think this is time to take this
next question
offline.
Yep.
What is the best way to minimize downtime when you want to synchronize the deployment and applying migration, or because it's a bit annoying?
That's a problem I think we haven't solved in Django yet. So you probably would need to have two versions of your application running where you deploy, you potentially would need to have two database servers where you and then split your entire stack into split it into half, apply everything on one half, then switch over to that application, apply the other side, and somehow make sure that the databases are still in sync. The problem there being that when you apply migrations, the models or when you apply the code and you reload the Whiskey server, you may already access the database, and this doesn't have new fields. So you could go with, well, let's apply a migration, but that only works as long as you don't remove fields, because then you access fields still access fields that don't exist. I think it's fairly safe to, as long as you don't do destructive operations in your migrations, which are remove field, for example, or delete model, you can go with, let's apply migration, deploy the code and reload the Whiskey server, but that still has problems with static files and stuff. So I don't think there's this solution to that problem in Django yet.
All right, last question.
Thank you. Hi. Should we keep using load data and dump data for initial data, or completely switch to data migrations?
As long as you don't use load data and dump data, well, load data in particular within migrations, you are fine. Calling the serializers in any way in a run Python operation does not work. It will blow up at some point. They don't use the models that are available during migrations. They use the models that are in your real code. So as soon as you do stuff with your model after this operation, this is going to blow up. So loading initial data as a one-time operation for like this test data you want to, yeah. I mean, load data generally is nice and a convenient way to, I think, migrate small sites from a staging to production and then do some adjustments. I tend to just stick to migrations and apply them because then I know that it will be there every time I deploy something.
Okay, that exhausted our questions. Thank you very much, Markus.